All right, fine. Now, the thing about chemistry is very wide. That's why most students don't like it. But we focus mainly on, we have in the syllabus, it's just inorganic, which is the toughest one, then the physical and organic chemistry. So we can't talk about chemistry without talking about matter. So we talk about what we call state of matter. And before we talk about matter, you can classify matter or anything under what you call the mole concept. So I will start with the mole concept. So from the mole concept, I'll graduate. I'll be very fast and I'll be direct. So when we talk about mole concept, because of all talk about matter. Early classes, you know what matter means. We don't need to start discussing about matter now. And when we talk about matter, matter is classified into different categories. So, and when you talk about classification of matter based on their chemical composition, matter can be classified into pure substance and also impure substance. Please, you make up a note. It's important because I'll be fast or too fast if you want to call it that one. So it can be pure substance and it can be impure substance. So when we say pure substance, we talk about elements and compounds. So now I can be making some notes for you and as well. So this is elements and compounds are pure. Elements, you put S there, and compounds. I hope students still remember definition for all these. Excuse me, you can always get that anytime. A mixture, you can categorize into two. They can be homogeneous mixture, and they can be heterogeneous mixture. Heterogeneous. So anyhow, please don't mind my spellings because I'm rushing. Write the correct spellings for everything. So the next thing we talk about, having said that, we'll now talk about definition of each of them. If there is any definition you don't know, you need to work on it and try and as much as possible to get it. So the next thing, which is quite important in the exam also, which you can't run away from, I may not want to talk about, but I need to talk about it, is the Dalton atomic theory. Starting from the scratch so that I don't have issues, and I will finish it in many 5 days for me. Atomic theory. And about that atomic theory, the important thing about him you need to put down is the first one is matter consists of what? You have every matter consists of indivisible atom. You know what we mean by that? That is matter can neither be created nor destroyed. So that's the first one. The second one is atom of the same element behave alike. Right? That's right. Matter can neither be created nor destroyed. Another postulate of his theory was that all atoms of a given element are identical, which is popular. We all know that as well. All matters, I will use abbreviation a lot. Identical. Identical means they behave in the same way. Another thing we can conclude from his postulates of that thing was that atom of different elements differs in properties. So atom of the same element are the same. They are identical. For atom of different elements combine in fixed ratio to form compound. That's another thing you can write. That is atom of different elements combined in fixed ratio to form a compound. So those are what he was trying to talk about. All matters are identical. Atoms of the same element, atom of different elements behave differently. That's another thing you can write down about his postulate. But those are the major things. Having said that, the next thing we also talk about after the Dalton atomic theory is what we call the laws of chemical combination. It's also common in all forms of exams. So about that, maybe we go to red. So laws of chemical combinations. There are many and they have applications, especially in some parts of your chemistry, combinations. There are many. The first one, we can just keep down a note, is law of conservation of matter, which everybody should know from basic classes. Or what is the law of conservation of mass? So students need to be careful about that. If it's a law of conservation of matter, I think that's law of conservation of mass. But it's not the same as law of conservation of energy in your physics, because you know how to define. It's important. Law of conservation of mass, or you say matter. Say mass or matter can neither be created nor destroyed, but it can be conserved from one form to another, or transformed from one form to another. The next one is law of constant proportion. Law of constant proportion, which you guys call law of definite what? Law of definite proportion. Definite proportion. Or basically it's called constant composition. Abbreviation to all this law has been stated in a Telegram group. The notes I've given sometimes like that, so you can always check it. So back to what I'm saying, law of definite proportion of constant proportion. That one is talking about when two elements A and B, all pure sample of the same element have the same mass combined by the same proportion by mass. I may not be stating all for now. I'll be stating them. I may not be writing all, but you can write the key point. The most important thing are what I'm going to focus on, because you know chemistry is wide and we have to finish everything before the day of the exam. The next is law of multiple proportion. Law of multiple proportion is also important. And about law of multiple proportion, that's the third law. You might be asked to state it. And about law of multiple proportion, that one is talking about when two elements, A and B, combine to form what another element. The varying mass of one combined with the fixed mass of the other are always in simple ratio. Like I said, all these are available on the Telegram channel. You can just go through them and make up your notes. So the last one, which is also important, is the one they call law of reciprocal proportions. Law of reciprocal proportion. So what that one is telling you is that when two elements B and C combine to react with the same an amount of the same amount of A, the ratio of B and C are always they are always in simple ratio too, and again provided that B and C are reacting together. That is what law of reciprocal proportion is stating. All these are called law of chemical composition, which you need to know how to define them, because in some questions theoretically you might be asked, and in some questions the numerical aspect of it will be treated when we start revision practice question. So, but before revision practice question, we have to talk about all this stuff, and that is the essence of this class before revision class. So another law I will talk about, because we are taking all the law together at one time, is what we call Gay-Lussac law of combining volumes. I also combine it to this law of chemical composition, which is also part of them. Gay-Lussac law of combining volume. Now that is even very simple to quote, but if you don't know it, go and learn it. It's also available on a Telegram note, short note. I've done something like the law state that if gases reacted, they do so in volume in which they are in simple ratio to one another, and to the volume of products if gaseous provided temperature and pressure to remain constant. That's another important thing. If gases reacted, so the law is only limited for gases. Please keep that at the back of your mind. So all these are called law of chemical combinations, and you should know how to state each of them. I have stated them. I'm rushing. You can make up your notes, and if you can record my voice, it's not a problem too. You can also munch the screen if you don't want to write too much. But it's better you write, because when you write, you understand very well. So the next thing I'll talk about is atomic and molecular masses, which is also quite important for JUPEP. Atomic and molecular masses. Let's take a note at this side. So I say atomic and molecular masses, or molecular mass, as the case may be. These are also elementary to some extent, or even to a great extent. Because if you have a good idea in chemistry before, this I believe should not be a problem. So let's focus on it. Let's take a green for all lines we will take. So if we go by that, I'm going to demarcate here, we have spaces. And we write it. So when we talk about atomic mass, I've told you time without number, it's just the mass of an atom, and it is always denoted by what? It is measured in AMU. When I say AMU, I mean atomic mass units. So atomic number, atomic mass first. Oh, wow. Let's go to a blue back. We have atomic mass. It's called, it's measuring AMU. AMU means atomic mass unit. So basically, it says the numbers of protons, and neutrons. So protons and neutrons, they also give atomic mass, which you can also call mass number. Mass number. And if you like, you can also call it numbers of what? Nucleons. I've told you, you are doing a level exam, you have to understand everything as though they were. The next one is the one we call atomic number, which it is denoted by Z. Atomic number. And about atomic number denoted by Z, it is the number of protons. Numbers of protons. So that is that about that. And basically, you can say atomic number is equals to numbers of protons. Mass number is equals to numbers of protons plus what? Neutron. So neutron is just mass number minus what? Atomic number. Early classes, you have talked about this. Mass numbers minus the atomic number. So that is that about that. And important strike about this one, which I think we need to understand, is that when we measure atomic mass, it is always measured in terms of what is exactly measured as 1/12 of one carbon atom. That is most important thing. That's where students make work mistake if they ask them to define atomic mass. And I'm talking about it because I know what JUPEP might ask you, or any form of examination you might be writing that is chemistry like. So you define atomic mass in terms of what? Basically, if somebody say define atomic mass, it is simply defined as the what? As in terms of what? Carbon. Everybody know carbon has atomic number of what? Atomic number of 6 and atomic mass of 12. So we say atomic mass is defined as what? As exactly equals to 1/12 of the mass of one carbon. So that is 1/12 of what? Of mass number of carbon. If mass number of carbon is 12, I know my network is not stable. You know, I said it is defined as 1/12. 1/12, that's 1/12, 1/12. Please, you spell 12. I don't even know how to spell 12 again now. 1/12 of the mass number, or the mass numbers of what? Of carbon atom, of carbon 12 atom. Because carbon can form isotope. So you just need to be careful about definitions sometimes when you want to pick up your chemistry is so tricky. It is very difficult for most students, and we understand the reason is because it is wide, cumbersome, and sometimes it's very tricky. You know, to pick answers, sometimes you can fall a victim of mistake. It doesn't mean you don't know it, but because you are not being careful enough. So we define mass number in terms of carbon atom. So carbon atom is like a reference. Do you understand? A reference frame. Now you know what reference frame stands for. To definition of what we call what? Atomic mass. I hope students get that. So we use carbon atom as that. And why do we use carbon atom? If somebody even asks me, it's so simple. I love chemistry so much rather. The reason is because carbon atom tends to have what? The same number of proton and same number of neutron. You can test that. Carbon 12 is number of neutron is also 6. Number of proton is also what? It's also 6. So the more reason why it was used by the man that did the experiment, and we are still coming to isotopes and other things, which I think I've done before. So you need to understand that, please note that. Now, the next thing we quickly talk about is your mole concept in, which is part of what I said. And about mole concept, I've talked about this time and time again. About mole concept, the important thing you just need to keep in mind. When we start questioning, you start seeing different methodology and approach. But for now, keep in mind the most important formula for numbers of moles. Mole is just a number. Mole is just a number, and it's given as the mass over the molar mass of the substance. It can also be given as a, because we need to keep formula down. It's given as a volume over 22.4. 22.4 decimeter cube, because dm cube. That is what you call MVG, molar volume of a gas. So number of moles can also be numbers of, it's also important, even in physics, the third one I'm writing is the numbers of particles or molecules, anyhow you want to call it, over AC, Avogadro's constant 6.02 times 10 to the power of 23 atoms. So these three formulas are important. You can add one to it. Numbers of mole is also equals to concentration times volume. So this will help you a lot. Its concentration is C, volume is V. So all these shorty formulas are very important for the concept of the mole. When we start mock test, practice question, we are going to use a lot of things, different approach will come in, then you see what I mean by this is just a preamble of what you want to face in question. So for now, we limit ourselves to most important thing and not beat about the bush. So that is what I'm trying to do. And I believe you guys are getting it. The next point I'm going to talk about is percentage composition. Now, early classes, you have also studied about percentage composition. And percentage composition in a compound is just the mass of that particular element over the molar mass of that element multiplied by 100. We can put it down in writing, which I will also manage this space for understanding's sake and for clarity's sake. Videos are available for you to watch. For those of you who are close to my side, you can always watch them. I'm recording all classes for future use because we can never say. You might also need to watch again some other time. So back to what I'm trying to do, I'm just trying to demarcate. So the next thing is I want to talk about percentage composition. And about percentage composition, like I said, in early classes, you might have learned percentage composition of a compound is just given as the mass of that compound over the molar mass of the compound, or you say molecular mass of the compound multiplied by 100. So that is that. And after talking about percentage composition, you keep this formula in mind. This is important. I will also take it. The next thing I can quickly talk about, there should be a demarcation here too, for clarity's sake. Fine. Now, the next thing I talk about is another important thing, which is empirical and molecular formula. You can see the way I'm breaking them. You know what, I'm going to touch every area by the grace of God. Empirical and molecular formula, which is another important thing you have studied also in early classes. Empirical formula, you say, is the simplest formula that shows the simplest ratio of an atom that is present in a given compound. This is the way we define. Now, empirical formula can be defined in terms of molecular formula. So what we do, which is the most formula you see everywhere you go, is that empirical formula equals to N, molecular formula equals to N. Let's just do that, which I think is even very important. That's the molecular formula of a substance equals to N times the empirical formula. Methodology and how to use all these will be taken when we start seeing questions. Times empirical formula. Please, I am not writing everything like I said. We focus on, and how do you calculate empirical formula from early classes? You might have studied that. And if you don't know how to study, the process are quite very easy. So you just get the percentage composition of each of the substance. After doing that, you list them out, as many compounds as you want to, as many elements that is forming the compounds. After doing that, the next thing you're going to do is divide by the relative atomic mass, which you call the RAM. So you're going to talk. So you divide by RAM. After dividing by RAM, you divide by the smallest number. So this is the way we compute the empirical formula, which I hope everybody doing this exam has already in one way or the other come across empirical formula. And if not, when numerical part of what, when we start doing questions, you are going to see as many questions that is asking on empirical formula, which you are going to do justice to. So I hope you understand molecular formula is just n times empirical. So after getting empirical formula, you multiply it by n, you're going to get molecular formula. These are the way you distribute right from early classes. I'm sorry for rushing. There are a lot of things to talk about. So please, another thing we relate to that is that you can talk about molecular formula or what you say molecular weight sometimes. It can also be related in terms of vapor density. Quite important sometimes. Molecular formula. I hope you can see what I'm writing. Is equals to the twice of the vapor density. So in some question, I can just give you a direct question. I know you've come across a lot. For those that are studying, you've come across quite a lot of this. They give you vapor density, they ask for molecular formula. You know what to do that. In some question, they give you vapor density and you want to relate it to what? You've gotten the empirical formula times 10. You have to multiply that vapor density times 2 before you equate it to what? The molecular formula. All these are important, please, and keep it at the back of your mind. So I move to the next slide where we take another thing. So now I'm moving. The next thing I'll quickly talk about because of those that are doing JUPEP and which is most important is what we call limiting reagents. Now, limiting reagents, some of you might be hearing that for the first time. I get in it, but what we call limiting reagent is a kind of reactant. We said there must be a reactant before you have product. So when the reactant, which is totally what consumed during the course of reaction, and what? And when all reactants are consumed, what do you think? Reaction must stop. We have learned from early classes that when we react, example, illustration is very important. We have reactant A plus B is yielding C plus D. I'm talking about limiting reagent, which is the next thing, limiting reagent. Now, I said this is the reactant, A plus B is reactant, products are C plus D. Everybody should note that. And if you don't know that, there is always a first time to everything. So I said when the reactant is totally consumed by the what? By the product. And the reaction will stop. So the reaction that is totally consumed during the course of reaction is called what? It's those reactions in which the reaction has been consumed by the product, like reactant has been taken over by the product. When that occurs, to balance that kind of reaction is very, very difficult. So what we do now is that you can see from what I've written here, A and B, like I said, are the reactant. And in this case now, if they have been consumed, that means everything here has gone. Only C and D is being yielded. So what we are trying to say now is that there will be a limitation for B and there will be a limitation for A. Limitation simply means conditions. So the situation whereby if we now want to know the amount of mole that is needed by B to form C and D, or the amount of mole that is needed by by A to form C and D. So a particular reagent that we add to the reactant to get the amount of mole that is needed to form a product when all the reactant has been consumed is called a limiting reagent. I don't know if you understand now. So my point is, now for every reaction, there is always a number of mole. Maybe we say number of mole is n here, number of mole is n here. So now what we are trying to say now is that if all this one has been consumed, we are now bringing a reagent, a particular compound or substance, as the case may be, to actually measure the numbers of mole of the reactant that has been consumed. Such reagent we call a limiting reagent in chemistry. So be careful about that. Now, numbers of mole, each of them, they are going to have numbers of mole, definitely, when you balance reaction according to law of conservation of mass or matter, which we have discussed. That is what tells us that all chemical equation must be balanced. You can always keep that at the back of your mind. Now, be that as it may, my point is a limiting reagent is just that reagent that measures the amount of moles of reactant when it has been consumed by products. I hope you have formed your notes. And if you need more, there are a lot of examples which we are still going to talk about later as we proceed. But I just want to talk about it in a nutshell. The next thing I'll talk about is concentration, which you all know. I believe you know what they call concentration of a solution. When we talk about concentration of a solution, these shorty things are very important. Concentration of solution. When you say concentration of a solution, you mean the amount of solute amount of solute in the solution. This is the way we define concentration. And I've given you the famous formula for it. Number of mole is concentration times what? Volume. Very important everywhere you go. You keep that at the back of your mind. So a lot of things are there for you to keep at the back of your mind. You can't say you are doing this class without writing. You're only deceiving yourself. I must tell you that. So the next thing I talk about, when we talk about concentration, we can talk about mass concentration. We can talk about mole concentration, which are what we are going to quickly talk about. Now, in early classes, these are a little bit of an experiment you might have done in early classes, and if not, it's still not a problem. So concentration can be divided into two for now: mass concentration and mole concentration. Mass concentration you call concentration in gram per dm cube, and mole concentration you call concentration in moles per dm cube. Shorty concepts. So the relationship between mass and mole concentration is mass concentration equals to what? Molar mass times mole concentration. So that means concentration in gram per dm cube is always concentration with the molar mass times concentration in what? Moles per dm cube. Another important formula you have to keep in mind for questions that we are going to talk about as we move forward. So be careful about all these ones, because they are going to be used generally and in our questions and in our question bank very soon. So again, you need to know also that you can also calculate the amount of concentration by using the process of titration. 10 minutes more for the end of this first section class. Now, under titration, you might have studied also that titration are of different types. But the common one you do everywhere you go is the acid-base titration. A quick one about that in this 10 minutes class: acid-base titration. About acid-base titration, which is the most commonest one, even for Jupiter practical, they are doing redox titration this year. Now, for acid-base titration, you are titrating acid against base. You know how to do that. And if you don't know how to do that, I am sorry, guys. You can always learn that as well. Watch video, but nobody will ask you to titrate acid-base for now. Now, when you titrate, definitely there are different solutes. I say amount of solute in a solvent is called concentration. So basic formula you from early classes is CAVA, that is CAVA, I call CAVA. Our CBVV is equals to Na over what? Over NB. This is the way we relate our titration formula. Concentration, C is concentration of acid. You all know this. And here we say the volume of base is volume of the pipette, taken by 25 centimeter here in my country, Nigeria, so centimeter cube. So all these are basic things which are needed as we move forward under the question bank. And when you talk about acid-base titration, we talk about indicators, which are also very important. Indicators, maybe I will talk about that later. They are used to note the endpoint of a solution. There are different types of indicator, and the commonest one you have methyl orange, methyl red, phenolphthalein. HN is called phenolphthalein. H-lin. This is the way we represent phenolphthalein. When I say H-lin, when I say lin, most of you think it's in. It is called lin. LN. It is not IN. Someone say in. It is called lin. Natural log. So H-lin. This is the way we relate phenolphthalein. Phenolphthalein, you know how to spell that. And if you don't know how to spell that, check this one out. So, and they change in color depend on the media. About that one also, maybe I give you a chart. This is just end of the class, almost end of the first section. So be careful about that when you are doing calculations on that. And I think I've done justice to that in my way. So please be very careful, because nobody will teach you more than that, what I'm trying to do. Now, the amount of mole in a given substance. Mole, number of mole is mass over molar mass. We've talked about that. Very important. So the amount of mole, I was giving you a famous one. I say N equals to CV, which is very important. Now, most of you need to be careful about the formula. When you are using the formula of N equals to CV, number of mole is concentration times volume. This concentration in this formula is measuring what? You say it's measuring moles per dm cube. And this mole per dm cube is also called, we call this molarity of a solution. So be careful. In some questions for JUPEP students, very important. Concentration of a solution is also called the molarity. This one only asks you to define molarity. Make C subject of the formula. So if you make C subject of the formula from N equals to C, it will be N over what? Over V. You can define in this term if you don't know how to define. So you say the amount of what? the number of what? Mole, the amount of mole that dissolve in 1 dm cube. And when we define in terms of 1 dm cube of a solution, the numbers of solutes that is present in 1 dm cube of a solution is called the molarity. The molarity, like I said, is the concentration. So most time, if you see a 0.5 capital letter M, this means the 0.5 molarity. And that's what it means, is what the concentration of the solution. Be careful about that, because it doesn't mean moles, but molarity, moles per dm cube. I have less than 6 minutes more to end this section. But before that, maybe I can quickly talk about that here. I don't want to start what I'm not going to finish. And that is why I'm trying to run away from what the next thing. The next thing I want to talk about is the gaseous and liquid state. And that under that, I'll talk about the state of matter, the distinction between state of matter. I'll talk about the shape, the volume, their position, intermolecular forces, particular nature of matter, packing orbit, Boltzmann constant, and other things that are important for this work. But I don't want to start it in this slide, but if I can just introduce it to it, we have defined matter as anything that has mass and occupies space. And when we talk about matter, we have different postulates of matter, kinetic theory of matter. I will talk more about it. We have different properties of matter between state of matter. Early classes, you said there are 3 states of matter. So that is the next thing I need to talk about, which I think it will not be enough for this video, states of matter. Let's start it, then we continue in the next one. You can click on the same link for continuation. So state of matter, for now, we are only limiting ourselves to what is required: solids, liquids, and gases. So we are going to take them with respect to their properties. They have different properties. We have video on this, but now there's no time to watch videos. We only limit ourselves or focus more attention on what is needed. So we talk about different properties. I'll talk about the shape. I talk about the volume. I talk about intermolecular forces. I talk about their motion, you understand? And if possible, I can also talk about the way they are being packed. That is their compressibility. If possible, I can talk about density, if time permits. So, and some other parameters you need on gases will be talked about, because most questions come on this, and I see that most students do fail this aspect because they don't know much about what kinetic theory of matter and all other things that is important. So maybe in the next slide, for now, we can just only introduce ourselves to some important properties like shape. So I will take it like solid, liquid, gas, like that. You understand? That is the way I think I can increase the pace. We talk about the volume, like I said. So we talk about intermolecular forces, the third one. So intermolecular forces. This is 3.5 minutes more. We talk about their particular motion. So which is also important, particular motion. And if time permits, I talk about density. I talk about compressibility. Hopefully, I can talk about that too in the next slide, compressibility and the density also. This is important. So we just take it for solid, liquid, and gas like that. So we can quickly take some so that we talk. We say solid have definite shape. Please keep that. Liquid and gas, they have indefinite shape. Solids they have definite shape, whereby liquid don't have shapes, indefinite. The same thing to gas, indefinite shape. There are videos on this. You guys, some of you actually have the videos. Some of you have watched them, but you've even forgotten. So the same thing about volume. Solids have definite volume. Liquid also have definite volume, but gases have indefinite volume. So definite volume. This is also definite volume. Volume of gases are indefinite. So that's that. The next one we'll talk is intermolecular forces. So for solid, they are cramped together. Like I do say in physics, we talk more about everything in nature are held together by different forces. Intermolecular forces are jingling around and collision and everything around solid particles. So when you talk about intermolecular forces in solid, it is very, very strong. Please keep that in mind. Strong intermolecular forces and what are there. So then the other one, the liquid, you said they are comparatively, they are not that weak, but comparatively weak. When I say comparatively, not that weak, but they are weak. So, but in gases, you can say there is no intermolecular forces. Or in English, you see everywhere you go, have less than 1.5 minutes more. You can say this one, they have strong intermolecular forces. Let me judge. I say this one, they have comparatively weak, using the word you are going to see. That is why I'm taking my time. And this, the third one, you say what? They have what? They are what? Their molecular forces are what they don't have. So you can say they are what? Negligible. That is what we see. Negligible. Please. Negligible. So please just don't mind my spelling for now. Like I said, it is not about the spelling. So when you say they are negligible, that means you can say they don't have what? Intermolecular forces. Do you understand? So the more they are cramped means the more they are together, the more they are intermolecular forces. So less than 1 minute more. Maybe I should stop here. Then in the next one, we are going to talk more about the way they move, about their particular motion. That is talking about solid moves with vibrational motion. When I say vibration, you know what I mean by that. Liquids are very slow and gases are very fast. And that is why they say they undergo random motion. Everybody knows that. So we continue in the next slide. Click the same link after a few minutes because this class is recorded. It needs to convert before we start the next one. So Eniola and the rest, please, the same link, no need to disturb me. See you very soon. Bye.